Hello guys, welcome to Matlab tutorial 3. So today I am going to demonstrate matrix operations. Since the concept of Matlab basically lies in a matrix operation, so according to me, this Matlab operation is basically based on matrix operation. So we'll learn matrix operation today, which is very basic and fundamental to the Matlab. So the first question comes, how to write matrix. So for example, we'll take array creation. So to create an array with 6 elements in a row, separate all the elements either with a comma or with a space. Let's take an example. Suppose I want to write a matrix defined by mat and square bracket. I want to create a row matrix, so you can write 1 space 2 space 3 space 4 space 5 space 6 and enter. This is row matrix. If you want to convert this matrix in a column, you can just simply insert semicolon after each element, okay. So here is column matrix. If you want to write row and column together, you simply write mat equal to square bracket. I want to save this matrix in a mat variable. I'll show you later. Here is the mat variable. Okay, I want to write row and column 3 cross 3. Suppose I want to write 1 space 2 space 3. This is first row. We want to separate row by column. So now again I want to write second row. Second row is suppose 3 space 2 space 1. Again semicolon. I want to write third row. Third row is 4 space 5 space 6 semicolon. I want to write fourth row. So 6 space 5 space 4. Just enter. So you can write row and column matrix. Okay. So here you have 3 columns and 4 rows. Okay, for demonstration purpose, let's go to Matlab variable. Here you can see similar matrix. What you can see here is a similar matrix saved in a Matlab mat variable. Okay, that's why we are giving any name. If you will not give any name, it will show you. Suppose I'm not giving any mat. Okay, I just press enter. So now it is stored in an answer variable. You see one variable is added, that is answer. Okay. Now the next goal is to find out. Suppose you want to print first column of a first row. Then simply write. Okay, I want to again store in mat variable. I want to write first row and first column. To write first row and first column, simply write mat bracket 1 comma 1. It will give you first row and first column element, that is 1. Let's see, it's 1. Okay, let's see, it's 1. Okay, I want to print first row but third column. Let's see, press enter. You see 3, it is 3 here. Okay, suppose I want to print second row and first column, enter. This is 3. You can see it is 3 here. Next I want to print third row and second column element. Third row and second column element. This is 5. You can verify it here, 5. Okay, so by this way you can create any matrix. Okay, row matrix, column matrix, row and column matrix, square matrix, any kind of matrix you can write, and you can get any elements of the matrix. Suppose you want to print, suppose you have mat matrix. Okay, suppose you want to print a whole row, okay, of a matrix. Suppose this is mat matrix. We want to print only row, so this is the syntax to print row. If you want to print column, simply write mat all this is the symbol of all comma 1. Okay, you can see, go to your variable window, you can see 1346 1346. So you can print anything you want to print. Suppose I want to print second column, all values of second column. Simply write mat bracket all comma 2. You see 2255 2255, correct? So this is the very basic operation in matrix. So there are several kind of matrix that are inbuilt in Matlab. Suppose I want to write a matrix, a square matrix whose all the elements are 0. So to write a 0 matrix, simply write mat z. Mat z is a variable where I'm trying to save the matrix. Simply write z e r o s zeros of 3 comma 3. I want to write a 3 comma 3 square matrix whose all elements are 0. Okay, simply press enter and see. Okay, so here you can see, go to variable, just simply write mat z. You can see all the elements are 0. Now you want to, suppose you want to print 3 cross 3 matrix, a square matrix whose all elements are 1. So you can write mat o. I'm writing, I'm just want to separate the Matlab, this mat variable by its command name z equal to 0. That's why I wrote z. And I want to write matrix whose all elements are 1. We will write simply mato equal to ones bracket 3 comma 3. Okay, just simply press enter. So I wrote here o because we are using ones command. I wrote here z because I was using 0 command, just to separate the variables, so to save the values in different variables. Okay, similarly you can write a random matrix. Suppose you want to write a random elements, you want to print random elements in a square matrix. So simply write mat r equal to rand. I want 3 cross 3 matrix, a square matrix, 3 comma 3. Simply press enter. So this is random. Okay, you can print the random matrix. Okay, so and next you want to write a magic matrix. The magic matrix defined as the sum of the element in each column and sum of the element in each row are the same. Let me demonstrate to the example. Let's write mat capital M magic equal to magic. I want to write a 3 cross 3 matrix. So here to write 3 cross 3, you need not to write 3 comma 3. You simply write 3. It will always take a square matrix. Okay, there is no asymmetry. I mean, other than a square matrix is not possible for the magic. Simply press. Okay, so just to demonstrate, you can see we will sum first row, that is 8 plus 1 plus 6. Okay, how much? It is 15. Now I want to sum this column 8 8 3 4. Let's write here 8 plus 3 plus 4, enter. So you can say 15 and 15. Similarly, sum of any row and any column. Suppose I want to sum second row, 3 plus 5 plus 7. Okay, it is 15. I want to sum third row, that is basically 6 7 2. 6 plus 7 plus 2, enter. So this is the magic matrix. Okay, so there are several inbuilt matrix in the Matlab that you can play with. Okay, so let's move to the another matrix operations. Suppose I have a matrix mat equal to, I will write another matrix, that is 1 space 2 space 3 semicolon 4 space 5 space 6 semicolon 7 space 8 space 9. So here is the matrix 3 cross 3 starting from 1 and ending at 9. Okay, suppose I want to add 10 in each element of the matrix. you simply so simple operation is simply write mat mat plus 10. You can see, just press enter. So 10 is added to each element of the matrix. You can see 10 plus 1 11, 18 8 plus 10 18, 9 plus 10 19. Okay, now so suppose you want to take sign of each element. Sign, I mean, that is, you can call this cosine. So simply you can write sin, sign of mat. You can save this in a variable mat underscore sign equal to. So just to separate all the variables, I'm doing this. There's no specific purpose. You can write anything else. That's absolutely your choice. Just press enter. You can see. So all the elements, suppose sign of 1. Okay, sign of 1 is 0.8415. So here it was 1. It took the sign of first element of matrix. Okay, so similarly all the elements, this command sign mat will take the sign of each elements of the matrix. Okay, now I want to take the transpose of the matrix. This is our matrix. This is our matrix. I want to take the transpose of this matrix. Simply write mat mat capital T. I will write mat mat capital T. Capital T is for transpose. Simply write mat comma. Okay, it will take the transpose. You can see row is converted into column 1 2 3. Your column is converted into row 147 147. This is the transpose. Okay, now I want to take the matrix inverse. I want to take matrix inverse. I will write mat mat inverse I equal to mat mat. So this equal to I and V. To take the inverse, simply write I and V bracket mat. So here it will display message that the matrix is badly scaled, but nevertheless you can choose your matrix. I just took for demonstration purpose. Here you see matrix is closed or singular or badly scaled. You can choose any other matrix. This is for demonstration purpose. Okay, suppose I want to multiply matrix. I want to make matrix square. I want to multiply two matrix. Suppose I have matrix 1. I have matrix 1 and I want to take matrix 2. Suppose I'm taking a matrix 2. Okay, here I will write 2, here I will write 3, here I will write 1. Okay, this is the matrix 2, and I want to take the matrix multiplication. I want to take multiplication of mat and mat 2. Okay, so simply write mat mat 3. I'm storing in mat 3 variable. Simply you can write mat dot star. Dot is used, and dot is important because you want to multiply each row and each column. Okay, so dot is very compulsory, and dot plays very important role. So do not forget to use the dot. It has a very great implications. Sometimes we do the mistake and we all often wonder why we are getting these kind of mistakes. Okay, now simply write mat 2 and press enter. You can see the two matrix are multiplied. Okay, now the third operation is, suppose I want to take matrix cube. I want to multiply a matrix 3 times, that is matrix cube. So simply write matrix, since I already stored 3 in the matrix, so for the cube I simply write underscore 3. Okay, equal to mat, okay, dot is very important, cube. Okay, just simply press enter. This matrix cube, you can see here the this is your mat. The 2 cube is basically, okay, here is mat. Okay, the 1 cube is 1 and 2 cube is basically 8. Okay, and 3 cube is basically 27. So here you can verify. Let's do it another way. mat mat underscore 3 and another method. This is second method, so I will write here 2 equal to mat dot mat. Let's see what happened. Can you see the same results you obtained? Okay, so you can do it by this way also. So I think it is easier way to do it, to perform this operation. Similarly, you can perform algebraic operations in Matlab. In algebraic operation in matrices, like suppose I have a matrix that is similar. This is mat. I have a matrix. This matrix I have. I want to multiply matrix. I want to multiply matrix with its inverse. Okay, so I will save it here. mat. Okay, mat algebraic. It is algebraic. So I will write mat star inv of mat. So we are multiplying matrix with its inverse. Okay, just press enter. Again you can get the same, because inverse singular is mean by its determinant is almost 0. Okay, the singularity is mean 1 upon 0. Okay, so it is badly scaled, hence it is badly scaled. Actually, to into inverse matrix is invertible only when its determinant is non-zero. Here it is giving it is obtaining 0 or close to 0 value. That's why it is saying this badly scaled. Okay, nevertheless you can choose something else. Okay, now we want to find the determinant. Okay, the determinant of a matrix. Suppose we have the same matrix. I want to find the matrix determinant. Say mat d for determinant equal to det. Okay, det of matrix. So since I told you to in my matrix is invertible only when its determinant is non-zero. So let's see what is the value of determinant of the above matrix. Okay, it is, you can see here it is almost 0, 10 to the power minus 16, as I told you. So the when you invert the matrix, you will get a singularity. Okay, now the third lesson is I want to find the eigenvalue of the matrix. So to find eigenvalue of matrix, simply write mat eigenvalue iv equal to, simply write eig eigenvalue of mat matrix. It will simply give you eigenvalue of matrix. There are 3 eigenvalues of the matrix. Okay, now suppose you want to calculate the eigenvalue and right eigenvector. So you have the matrix. I want to calculate the eigenvalue and right eigenvector of the matrix. So syntax is simply write a square bracket v space d equal to eig of matrix mat. Simply write. So you can see these are the eigenvalues that you have already seen in the previous operations. Okay, so to wind up with this lesson, last thing is you want to rotate the matrix by 90 degree. You want to rotate the matrix. This matrix is basically, in a broader sense, are the operators that you will understand when you will go for higher studies. This matrix are basically operators. Now if any operator operates on a coordinate axis, that is called as basis. So if your basis is rotated by 90 degree, if your axes are rotated by 90 degree, so your matrix has to be rotated by 90 degree. Okay, so how to rotate the matrix? Suppose I want to rotate my matrix. Okay, this is our matrix. I want to rotate it by 90 degree. So here is the simple command mat. I want to rotate, so I will write arrow equal to rot. I want to rotate it by 90 degree. So simply press insert 90 bracket mat. Okay, the matrix is rotated by the 90 degree. Okay, so we have learned several matrix operations. Okay, So this is the end of this session. Okay, you can leave your comment in the comment box if you have any kind of query or any kind of doubt or anything. If you did not understand anything you want to know, you can leave a comment in the comment box. So in the next tutorial, I'll bring again a second basic and important thing about the Matlab, that is trigonometric operations, and I would like to contain some complex variable operations if time will permit. So I don't want my video to be more than 10 minutes, so if time will permit, then I will include it. So but this matrix operation is the heart of this Matlab that you should understand at a first. And the tutorial 6 will be very important, that is the algebraic operation. That is your aim. Finally you'll have to understand the algebraic operations like solving simultaneous equations, solving differential equations, solving different order differential equations, and many more things that you want to perform in Matlab. So the 6th tutorial will also be very important. So my introductory of the Matlab will finish within the 6 tutorials. Thanks for watching the video. If you like it, please share it as well as subscribe to my channel. Thank you so much.